Welcome to Neural Nebulae, where we unravel the mysteries around artificial intelligence, clear up misconceptions, and explore the transformative impact on industries, various use cases, and important considerations you need to make when you embark on an AI journey. In today's episode, let's explore AI benchmarks. My name is Kenneth, Henrichs, Senior Customer Solutions Architect at Caylent, and joining me today is Brian Tarbox, an AWS Community Hero, AWS Ambassador, and Principal Solution Architect at Caylent. Let's get right into it. Hey, Brian, nice to talk to you again. This sounds like a very exciting topic, one that may be slightly objective, very subjective.
Yeah, benchmarking AI and models. It's a, I don't know. It's a tricky topic. It's a tricky topic as everything is changing all the time. And you know, since a lot of what we're talking about is generated content, it goes down to the age-old question of how do you quantify creativity?
Yeah, exactly. That's a great point. And along the topics of benchmarking, I mean, in general, you benchmark something to make sure that it's performing to your expectations, and it's not just a pass or fail. But in this situation, I think it's also important because there may be more than one model that can solve a problem, and benchmarking can help highlight where the more economical or the more efficient or more effective model is. So that also alludes then that there are different models that could be chosen between. Let's start off pretty high level. What are some of the differences between models out there when we talk about generative AI?
Well, that's a great question, and this is a topic that has been much on my mind for a variety of reasons that I'll allude to. There are, I mean, you can look at the models from a bunch of different perspectives. There's the parameter size, there's cost, there's throughput and responsiveness, and what they're good at. Is a particular thing good at textual summarization? Is it good at creating bullet points from ideas? As we move into more of the multimodal models, how realistic are the images that it creates? And then that drifts right into how biased are the models, and so on. I mean, it's sort of become a joke. I saw I don't know if you've seen the whole Scarlett Johansson voice controversy that's been going on.
Yes, I have.
And so there was and that's a whole interesting thing of itself. But on The Onion, of course, and it's hard to tell The Onion anymore, but they had a picture of Scarlett Johansson saying that she approved of the use of AI to mimic her stuff, and they made a point of giving her in the image 7 fingers on each hand. So it's it's a question: do we want verisimilitude in our images, or do we want them to be able to be kind of strange? And I think you didn't really ask this part, but I think we're moving away from the notion of one model to rule them all, in that if you set the Wayback Machine, to 20 generations ago, which in our case means 6 months, it was, I need a billion parameter model, I need a trillion parameter model. And I think we're moving more into the notion of we have a variety of different models, and then maybe a model on top of them that picks which model to actually use for any given thing. Now, it's funny, I've been looking at this for a talk that I'm doing down at the New York Summit, shameless plug, and I've been rereading Marvin Minsky's The Society of Mind, a book that came out in, the late 70s, I think, and is still on target, maybe more on target now than it's been for 20 years, where he talked about intelligence being a collection of agents, each one of which wasn't necessarily intelligent, but they could do particular things. And then the intelligence was an emergent property from the bunch of them. And emergent properties are so interesting. So I don't know if that had anything to do with the question you asked, but
Yeah, I think so. And there's a couple of things that I wanted to highlight, but then also ask a question about one of those. So, you talked about some of the differences between the models would be things like throughput or accuracy. You also talked about the number of parameters. Could you double click a little bit more into parameters, specifically because I think that is one of the metrics of AI models that's more visible, especially to a non-technical audience, because you get into things like the Llama 70 billion model. And so, that particular metric is part of the actual name of it, but I think there's a lot of people that just don't quite understand what that means. Could you talk briefly about that?
I don't know if I can talk briefly about it, but I'll give it a shot. What people need to understand is, basically what are these models? We take the process is to take an enormous amount of data and vectorize it, and then adjust the weights, between the vectorized instances. And that the usual example is that you want kitten to be somehow closer to cat than dog, and then puppy to be closer to dog than cat. But what does that mean? What does it actually mean to be closer? And I think that the way that I think about parameters is just the level of complexity. And I started doing AI. Well, we didn't really call it AI. Well, actually, we did call it AI, and then people realized, well, you can't call it AI. So I'm not sure what we would have called it back then. But when neural networking was just coming out, when it was first started, and oh my God, on an IBM 286, you could run a model with an input neuron, maybe 3 middle neurons, and then an output neuron, and that would strain the heck out of your system. And the system would learn by adjusting the weights. Now, the analog to biological cognition, of course, is adjusting the weights between your synaptic in your synaptic connections between the axons and the dendrites. And I'm probably going too far down into biology, but basically, in a human brain, in any brain biological system, you have neurons that are connected, but there's actually a gap, and that's the synaptic gap. And you have neurotransmitters go across, and you'll have a bunch of neurons impinging, and there's an activation. And I realize I'm going way too deep, but that's okay. Or they'll cut it. I don't know. And the amount of neurons that fire before this secondary neuron fires, that's adjusting the weights. And that's essentially what vectorization is doing. So it's a measure of complexity. And it's maybe I'm actually giving you a meta answer, in that I may be giving you an answer that's way more complex than you actually asked for, but maybe that's what an overly complex model does. Maybe you don't need that for text summarization.
Yeah, and doesn't that tie back into your statement earlier about how there's not really one model to rule them all? And so if I'm hearing you correctly, then what you're saying is that a model that's got more parameters, or the same model that has separate versions, one with more parameters than the other, knows about more information. And I would assume then that the more information it knows about, the more accurate an answer potentially could come back, but also there's probably more cost in creating that model and licensing that model or using that model and then running inference against that model. Would that be correct?
Right. And the one place where I might caveat just a little bit is when you said it knows more. And that's a whole multidimensional answer, which is why all of this becomes so complex, and that I can know facts. And if I know more if this knows more facts than this, perhaps this is smarter, but this might know more of the interconnections and more of the relationships. So a larger model is sort of by definition more complex. So it might have, I hesitate to use words like understanding, because these models don't understand anything, but a more complex model gives the appearance of more understanding, generally.
Got it. That makes sense. So, with all these things being said, we know that it seems to be very common now for new models, new versions of models to come out. We're seeing models pop up across all the different modalities. We've got image models, we've got video models, we've got speech models, we've got code models, we've got text models, et cetera. With all those out there and all of them being different in how they perform and what their costs are and things like that, I understand the importance in benchmarking those. I guess you can select the right ones per use case and not just trying to pick the one size fits all like you had mentioned earlier. So when it comes to trying out those models and benchmarking those models, what are some common benchmarks that people use today to measure the effectiveness of any one of these given models?
Well, that's a great question, because what's the effectiveness depends. I mean, what you measure as effectiveness depends on what you're trying to do, and very often we'll use one model to measure the effectiveness of another model. So one standard might be to take a page of text and summarize it using one model, and then that becomes sort of the answer. And then you can use different models to summarize that same original source text and see if it comes out to be anything similar to the correct answer. But then, of course, you have to judge similarity. And so you may need a model for that. Did it give a similar answer? It's a lot harder than in our old, C or Java or Python unit testing, where it's like, the answer is 3, and I have a unit test, and did it come up with the answer is 3? It's harder to know, and especially with visual models. I mean, if I say, create me an image of a Pegasus dolphin, okay, I know I want something that looks like a dolphin that has wings. But how you would score that, and where's the bounds between creativity and doing it wrong? I think we're just starting. So I guess the answer is, I think we're just starting to figure out how to do benchmarking of visual creativity models. If we go back to the old days of machine learning, where we were trying to do facial detection in an image, or semantic segmentation, find all the pixels in an image that are the vehicle or the pedestrian or whatever. It's a little more cut and dry. But whenever we're talking about creativity, measuring the correctness of the answer becomes hard. So I think we're early days.
Yeah, and I think that's a really good point, because AI has been around for a while, and we've always had the ability to measure the accuracy and performance of AI models. And the reason why this is such a very important topic is because the landscape has really changed. With the traditional analytical models, we could use objective evaluation of those to determine, are they getting the right answer or not, because there was a definitive right answer or wrong answer that you could quantify, you could measure, and you could understand whether or not it was giving you accurate information. But I guess what you're saying is that because these generative models are creating new content, that there is absolutely a subjective level to, did they create content in the way that you expected, but also that's acceptable to whoever's trying to consume the output of the information from the model.
Right. I mean, at some point, because we want to automate all of this, of course. And so we don't want a human to be reading 2 paragraphs of text and deciding, scoring them whether they're similar, to what degree they're similar or not. Although, you could call that ground truth and do that to some degree. But I can assume for measuring summarization models that you would want another model that would be able to say, are these 2 paragraphs similar, or to what degree are these 2 paragraphs similar? And you might have to do ground truthing on that scoring model, but then you could take some standard text, but it would have to be a whole corpus of standard text, because it's talking about different topics and so on. and then run different summarizers against that and run the scoring model on it. But again, the different models. I mean, look at things like Dragon Dictate, the speech recognition systems. They have the different versions of that. They have the one that's specialized for medical dictation. I mean, I remember I used to use Dragon quite a bit, and I was doing video on demand processing. And so the system had to learn that when I said cache, I meant CACHE. So it's a complex area. And I think if I were telling someone to get into a field right now, getting into the field of figuring out how to do evaluation of the output of these systems, that's probably an area of quite a lot of activity right now.
Yep. So on a related note, what I'm often seeing with my customers is whenever they want to, let's just use the use case of summarization of documents. We see this a lot in the legal arena as well as the medical arena. Let's take a bunch of medical notes, visit notes, et cetera, and let's summarize what's happening and then ask questions and get answers out of it. Same thing for legal proceedings or like deposition recordings and things like this. So if you take those use cases when you're doing summarizations, oftentimes it starts with, let's pass some examples through several models and let's just look at the output and have a human say, yes, this looks good, or no, this doesn't. You talk a little bit about maybe using another model to validate how different or how similar different outputs are. But at some point you get what you would say is decent enough confidence that you're getting good quality output. And I'd imagine at some point you can roll back the human in the loop aspect of it and let the thing go a little bit more unmonitored, but you would still want somebody to check in periodically to a sample of those things to take a look at the quality and make sure that the quality is still producing results. And in other words, this is not something that you're ever going to get to ideal quality and then turn loose and then forget about. You need to stay on top of it to make sure that the results that are being produced are still in line with your expectations, especially due to the subjective nature of it, right?
Absolutely. Well, I mean, that's been true forever in machine learning as well. I mean, it's, the classical situations, I'm using machine learning to figure out predictions on which sneakers are going to sell best. But, as the world evolves, you have to update your model, for seasonality and just style. And I'm sure all clothing prediction models are going to change due to climate change. It's like, hey, everything should be short sleeve now. So yeah, I mean, I think it's all of these things are sort of arms races where you do what you can as things are adjusting, but you keep having to periodically check. I mean, in any industrial assembly line, you still occasionally take off one of the units off the assembly line and have a human look at it.
Yep.
I mean, God, I hope they still do that. So, yeah, automated systems are good, and humans have to occasionally check as well.
Yep. Okay, excellent. So a lot of the models that we work with are either deployed through Bedrock or through SageMaker. So I've heard of something in Bedrock that has the ability to do model evaluation. At a high level, you can benchmark some of the text models, but I don't think it can do things like images. And so I still think that if you're using Bedrock specifically, you would need a human to look at those images. But it's looking for things that has the ability to measure for things like the accuracy of output. Like I don't know how it works, but I know that it can. The accuracy, the robustness, or the toxicity of a specific model for your use case. But I think more importantly is that once you've defined how to measure these things, you can execute it across many models to get those measurements across those models using the same scale or the same measurement mechanism, which is maybe just as important, if not more important than the measure itself, is being able to look at those values across different models to make sure that you're getting the right one or the one that's the best equipped for the use case that you're trying to solve.
Right. Well, and you've sort of veered into an area that I'm really sort of hot about when you talk about toxicity, because there's a study. I actually just read a study yesterday that was looking at how GenAI models work from a different cultural point of view. And there's this wonderful acronym, I'll see if I can remember it, called WEIRD. Western, industrialized, educated, rich, and democratic. WEIRD. And basically, they measured countries on how weird or not weird they were. And, it's basically, U.S. is right down the center. And GenAI systems gave culturally appropriate answers really, really well for countries that were like the U.S. And for countries that weren't, the answers were not culturally appropriate. So I noticed in particular Japan, New Zealand, Singapore, a lot of countries, the answers just weren't right, which makes sense because, these models are going to emulate the training data. And where's the training data coming from? Lots and lots of it has come from the U.S., so it's going to match the U.S. And most of these models largely miss the cultural nuances. And so, I think toxicity, is part of that. If you're an American and you travel around the world, how much personal space do you get? Do you give someone? Do you make eye contact? Do you smile? Do you shake hands? There's all these different cultural things that some countries view as some of these things will be viewed as very positive in some countries and very negative in some other countries. There's countries where smiling at a person is not considered, or is considered rude. And so if your model says, "Oh yeah, you should always smile at people," it's like, well, that's going to be inappropriate a lot of the times. And so what's toxicity? So I think we are, again, I just go back to it. This feels like really, really early days and ethnocentric.
Yeah, and I think it's an important point, because what you're underscoring is that there's not a universal set of values and beliefs across the world. And so in addition to these already subjective metrics that you could be trying to measure in these generative AI models, you've also got the additional complexity of things that are culturally accepted and unaccepted across different cultural barriers. I'm thinking about very simple things like in Japan is more of a collectivism type culture, and in the United States, it's more individualistic. And so if your target audience is in one country or the other, that's something that you wouldn't normally think you would need to be aware of in your software necessarily. But if you have a chatbot, for example, or a Q&A type thing, or a knowledge base, then some of the suggestions may need to be guided around those cultural sensitivities, or I guess even the models that they're trained on, what is the cultural bias that it already has in it? Is it slanted towards one culture versus another culture, and understanding those types of things where you may or may not need to enforce additional guardrails.
Right. And to what degree are they amenable to changes in the prompts? So, we typically say, "You're a really good Python programmer. Write me a Python program that does blah, blah, blah." But it also could be, write me a script for a greeter at a big box electronics store. And by the way, you're located in Japan. To what degree would they understand that? I go back to, I used to work at a company that did call center monitoring, and we would listen to the interactions between the call center agents and the end users. And we would say things like, "You're speaking too fast, you're speaking too slow, you have high energy, you have low energy," and so on. Well, we found that worked very differently in, say, Georgia versus New York City. It needed to be scaled, and I think a lot of this is going to go back to, changes in the prompts and changes in the context. When we say you're an expert Python programmer, well, that's great, but that doesn't carry over until tomorrow. the next time you fire up that model, it's base model. It doesn't remember. Now you can, adjust that by keeping a history and keep feeding the history back and back and back. But there's a limit to how far you can do that. Whereas humans, I think the example is, or the analogy is that we humans do fine training all the time. And we don't typically consider every interaction with an LLM a fine training example. But, it might be that you have to fine train a model to be the, Savannah, Georgia customer service rep versus the New York City customer service rep, and so on. And then you have to model evaluate them differently.
Yeah. So in those situations, sounds like there's two important aspects. One is identifying that there's some context that you need to include when you're prompting or when you're asking a model to produce content. So your Savannah, Georgia example, that would be part of the prompting or the training or the tuning to teach the model or make sure the model understands. And the second thing is making sure that the model has the ability to apply that context to the output that's being generated for you so that it's still meeting your needs. So I think, there's some pretty simple examples, of using these chatbots, but they get pretty sophisticated. And I've found that the accuracy of what they output is a lot of times governed by the quality of the input. I think you even had something you wrote recently about it, comparing LLMs to teenagers, right? In that same vein.
Yeah. Right.
Yeah.
Right. Teenagers and LLMs are always very, very confident, whether they're justified in that particular moment or not. I will say as we were doing early work here at Caylent, one of the things we did in one of our sort of answer bots was add the ability to say, "I'm not sure," and I thought that was brilliant, and that's critical. If I'm talking to someone, even someone who's an expert, and I ask them a technical question and they say, "I'm not sure," man, I respect that. Tell me I'm not sure rather than blow and smoke. But that also then gets into sort of the whole notion of emotionality, in that I've started playing with the system from Soul Machines, where they generate an avatar that you can have a conversation with, and the avatar appears to pay attention to the emotionality that you're presenting to it, and it appears to be speaking with some emotionality in response. I was at a user group meeting just recently, and they the host brought up a bot that supposedly knew a lot about whiskey, and so I asked it about putting drops of whiskey or drops of water in the whiskey, and it said, "Well, that can bring out the aromatics, and so on and so on." And then I asked it about mixing whiskey, and I said, "What about mixing a whiskey with Kahlua?" And it sort of looked horrified, and it said, "Well, a lot of people would find that just blasphemous, but I suppose if that's your tastes, so be it." And so that it's just really interesting to see, as we're beginning to incorporate emotionality into these things, the range of behavior gets bigger and bigger. And I suppose if we're just, part of the thing is that the solution space is just expanding. If it was just, "Hey, summarize this text and just give me the gist of the text," that's one thing. But if it's, "Hey, how you doing? And, you're talking a little slow, so maybe I wonder, are you having a down day?" Well, that's a whole different ball game. And, how you measure or evaluate any of that, I don't know.
Yeah, that's probably an area that's somewhat light or minor today or untapped, but something I would imagine we would see as we continue to try to make these things more and more human-like and less robotic. Still likely a lot of smoke and mirrors behind the scenes, but
Right. I don't think this bot that I was talking to likes whiskey, knows what whiskey is, has ever tasted whiskey because it's a bunch of electrons. But it gave a much better impression than I had seen 6 months ago, or certainly a year ago.
Well, these are good examples, and I think really for anybody who's interested in the topic of benchmarking, there's some important things to take away from this. I think maybe not as clear cut as here's your checklist, 1, 2, 3, do these things, and all of a sudden you've effectively benchmarked a model. But these are things to be aware of to make sure that you're going in with eyes wide open. You talked early on about there not really being a standard approach yet. No one's created that because we can't even define exactly how to measure the effectiveness of these models, because that metric varies across use cases, across companies, and then importantly, across cultural barriers and things like that too. There's bias and unfairness that can come out, and you talked about being able to use the context of the prompt or of what you're programming your model to do, to be aware of those sorts of things. And so it's you knowing up front that bias and fairness or unfairness could become a problem, being able to train around that, tune around that, prompt around that, but also measuring to make sure that that's not something that's coming up. And then something that we didn't necessarily talk about today, but I've also heard a lot about, is explainability and being able to get back to how you know something. So like in the cases we talked about where we're summarizing information, I've seen it often where you summarize a document, but then you have links back to that document that says, here's the paragraph that we got this summary sentence from, or
Right.
out of an entire canon of information, this is specifically the documents that we got this summarized paragraph from, which I think is important.
Right. I think that's becoming table stakes. And I will say I generally use Perplexity.ai as my system. I really don't use Google. I prefer it over chat, just different strokes, and I certainly prefer it over Google, but it's become table stakes that you're presenting me some information. Well, give me the links, because then I probably do want to go back to the links. And first of all, just to verify that you got it right, but also I might want to go a little bit deeper, and it gives me more confidence that it's doing the right thing. It's tricky, because one of the things is I think a lot of people are using these systems, be it Code Whisperer or Copilot. A lot of this is being done by tech people on tech topics. And so if you're looking at the corpus of GitHub or Amazon's, however large their whole documentation set is, there's not a lot of room for bias. What's the API for EC2 terminated instance? Well, it is what it is. It doesn't matter what country you're in. It is what it is. And I wonder if we're getting a bit of overconfidence in these systems' abilities to do more out in the field things where the world isn't as cut and dried. So I mean, it's going to be interesting to see to see how it goes. But so I don't know. I mean, I saw a report just this morning that was claiming that the number of people who are actually using these systems is much lower than people might expect. It, of course, is all of us. I mean, we're using it all. I mean, anyone who's listening to this or watching this, we're probably using it, all the time. But outside of the outside, when you get to a little bit further away from the laptop, maybe it's a lot less. Yet.
Yes. I think there's one other thing that we haven't touched on today that I think also is important, where one of the first things that we did at Caylent when these LLMs became all the rage is created a spreadsheet to help compute the relative cost of using them, because you've got in general, depending on how you're, if you're self-hosting your own model, then obviously you're just paying for your compute. But if you're using these through a service like Bedrock, for example, then you're paying for token counts, and that's maybe a little nebulous for some people. Roughly has to do with the amount of information passed in and passed out. But regardless, when you're using a model, if you get away from the subjective type performance measures, you do have some objective measures to where you've got the speed that you start getting a response back. the speed that you get the final line of your response back. You've got the cost for your input tokens, the cost for your output tokens, and these will vary wildly from LLM to LLM. And so in addition to measuring how effective they are at answering the question or performing the task or generating the thing, whatever it is that you're doing, you also have to take into consideration these costs, because maybe a model is able to produce 10% higher quality, that being a very difficult metric to track, but let's just say it's 10% higher quality, but it's 2x the cost. It may not actually be worth it. It may be acceptable to take that model that's a little bit lower in quality, but understand that it's going to save you so much in the long run that it just doesn't matter for that particular use case. And so I think these are important dimensions then to feather into decisions when you're trying to choose a model, right? It's not only the quality of the output, but also the overall cost and speed at which these things can return.
Right. And then you get into sustainability, because remember last year at reInvent when Werner Vogels was talking about sustainability, and we're adding a pillar to the well-architected pillar about, environmental cost. I mean, there are reports, for a while there, it was Bitcoin mining was consuming X% of the world's energy budget. And now people are saying, model building, model training is consuming, a crazy amount. And Werner was saying that, in some cases where you don't necessarily need the absolute, 10 nines precision answer, maybe use a smaller instance, because then your carbon footprint is a little bit lower, which is good for the world. And so your cost is a little bit lower. I think the same is going to start applying to model selection. I mean, I think you have to assume that using a smaller model to some degree has a smaller carbon footprint than using a giant model. And if I'm doing text summarization, that's a sort of best effort thing anyway. Is the absolute best summarization of a piece of text. How much more important is that than pretty good? I'm summarizing the model, or I'm summarizing the text. So there's just all kinds of dimensions that we're only beginning to have any idea how to even think about.
Yep. I recently, we built this thing internally called the Bedrock Battleground, where you can add one-to-many LLMs to give the same prompt to, and you can watch them come back in real time with their responses. So it's streaming the response back. And it's really interesting to go through and pit those models against themselves and take a look at, there's so many cases where the responses are very, very similar, like surprisingly similar. When you're asking for things like outline a training plan for teaching people how to get public presentations is one that I went through recently, right? And it was crazy how out of 3 LLMs, 2 of them had a training plan that was 80% overlapped, and then the third one was just kind of out in left field. And I think it's a really good illustration of where you may get similar responses out of these 2 models, but when you look beneath the surface, you can look at the cost of these 2 things, and they're wildly different. And you're right, it's not just about your pocketbook and your scalability at the end of the day, but also not burning through a lot of unnecessary electricity just for the sake of burning through that electricity.
I have a vision of a TV show. Did you ever see BattleBots, where you have the robots?
Yes.
That was, and BattleBots, and when you said Bedrock Battleground, I thought of. So I'm not quite sure how it would work, but I could imagine having the various models battle themselves out, and they would kind of like a combination of Deep Racer and Bedrock BattleBots, and they might have a limited battery supply. So if they spent too much of their electricity on the first questions, they wouldn't have anything left for the last questions. We need to get one of our TV customers to get in there, because this could be the ultimate geek game show. Deep Racer Bedrock BattleBot.
I love the idea. We got from my son once a portable battleground for those BattleBots, and they came with 2 bots. One had a hammer, one had a saw or something like that. And it was fun watching the kids play with that. I think we could weave AI into that somehow. Ask an LLM something and then represent it with an attacking robot.
Well, as soon as we're done with this call, the first thing we're going to do is fire up Perplexity and say, I want a game show based on this premise. Write it up for me.
There you go. There you go.
and then tell me if it's a good idea.
Yes, using a different model.
Yes. Evaluate whether this is a good idea.
Awesome. So a couple of important considerations that at Caylent we've been saying since the GenAI boom that I think go hand in hand with the need for these benchmarking of LLMs and doing these comparisons, the multidimensional checks of cost versus performance, throughput, et cetera, is that, and you mentioned this a little bit earlier too, is it's very important to remember that there's not one model to rule them all. That on purpose, there's not one model that can do everything. And the reason for that is so that you've got the ability to pick purpose-built models that can solve a use case or even portions of a particular use case. And so you should expect that there's going to be multiple models. Within that, these things are evolving so drastically that it's also important to make sure that solutions are not built around one particular model, that a model is just one piece of the solution. And that sounds like two sides to the same coin, but what we really mean is that if you start to use one of the Llama models, for example, and you build your entire solution around it, and it was Llama 2, and now Llama 4 is the thing, and Llama 2 is no longer supported, and you break your entire ecosystem by ripping out that LLM, you've done yourself a disservice. I think we're seeing technology evolve at a much more rapid pace with LLMs than we've ever seen. And so I think that type of technical debt is going to be amplified. And by building your solution around your customer experience and then plugging these generative AI models in where they can fit and solve problems is a more scalable architecture and minimizes the impact of that kind of industry churn. Any additional thoughts or comments there?
Yeah, well, I think, I mean, not to sound like an Amazon shill, but I think that's kind of the brilliance of Bedrock. I mean, yeah. Amazon is coming up with, its own models, but it's also partnering, like with Anthropic. But yep. A large part of the value proposition of Bedrock is, hey, plug in the model you want, and we're going to have an abstraction layer on top of that to shield you from that. Engineers, we always say there's very few problems that can't be solved by another level of indirection, and especially when the world is changing at a crazy rate. I think Bedrock is a really good approach to that. And I think we, as always, we go back to just because it's AI, don't forget all your standard engineering goodnesses. Low coupling, high cohesion, keep it simple, keep it isolated, make each of your things do one thing and do them well. I mean, keep all of those and put those don't go away just because we're dealing with AI. They probably become more important, especially because we always also have the problem of, a POC escaping into the wild and going into production. And since AI systems often look like they're doing something amazing, it's pretty easy for a POC to get promoted into production. So you got to protect yourself against that.
Yep, great point. Well, I've really enjoyed this conversation. As always, I learn something every time I talk to you, and
right back at you, man.
I certainly appreciate it. I think this is it's an easily overlooked topic, but I think it's one that's extremely important. That customers stay aware of, especially as everybody's embarking on this new journey together. So that concludes our episode of Neural Nebulae. We hope to leave you with something to think about as you pursue innovating with AI. If you enjoyed the show, please leave us a rating and review on the platform you're listening on, and don't forget to subscribe so you never miss an episode. Thanks for listening, and we'll see you next time.